Hey everyone, moving on to the fifth technique in our Maclaurin series, we have the trigonometry expansions. Similarly, these expansions are found in the MF26, and if you notice, their expansion is actually very similar. Alright, the technique is very similar to the exponential, because if you look at this, there is no constant, but only a fx. So what does this mean? So it means that if there is a constant in the trigonometry, right, you have to use the addition or subtraction formula given as sine a plus minus b or cosine a plus minus b. Okay, so it's slightly tougher now because unlike exponential, so you can just easily factorize out, right? So in exponential, if let's say if e power a plus fx is simply just ea times e power fx. But in trigonometry, you can kind of take the long route, and you might, sometimes require even more expansions. But unfortunately, this is the case. So fx cannot have any constants. All right, constants. Okay, so let's take a look at two simple examples. So let's say we have sine. All right, it's all very simple. Sine 3x. All right, same thing. Replace every x with 3x, and let's say again we are only interested until the power 3. So first up, we have 3x minus away 3x whole thing cubed divided by 3 factorial, which is 6. So plus dot dot dot, because obviously if you go to power 5, then you'll be power 5. So from here, it's just simple. So we have 3x minus. So how I do is very simple for arithmetic, right? So I know that 3 divided by 6 will give me back half. So below will be 2, on top will be 3 times 3, 9. X cubed plus dot dot dot. Alternatively, 27 over 6 gives you divided by 3, 9 over 2. So simply, sine 3x give us an expansion of 3x minus 9 over 2x cubed. Let's give you a slightly tougher example. Let's say we have cosine x squared minus x over 2. So again, up to the cubic. So first term is always 1, so let's just follow that. First term will be 1, minus away, now we have fx squared, so x squared minus x over 2, whole thing squared, divided by 2 factorial, which is simply 2, and then obviously we're not going to include the x power 4 term because the minimum degree would then be 4, which is higher than what we want, so we can simply replace it with plus dot dot dot. Now we just expand, right? We just want to cubic. So let's look at our expansion. Our expansion have x squared, so our highest degree is 4. Alright, so we can ignore the x power 4 term, but let's start off with the bottom term, which is degree 2. So if x over 2 squared, which will give us x squared over 4 over 2, so x squared over 8. Inside becomes minus, so minus square will become plus. So ultimately, there's a minus sign outside, so it becomes minus x squared over 8. Inside, so now the cubic term. We have x squared times x over 2, we need times 2 again, right? Because as per usual, if we have x plus b square is basically x squared plus 2xb, right? So 2xb, so 2 times x squared times x over 2 will give us minus x cubed. So minus x cubed becomes plus x cubed because of the minus sign outside. So I get plus x cubed. Now I divide by 2, divide by 2. X squared minus x squared squared will give us x power 4, which is not what we want. So we can simply ignore that and then just add a plus dot dot dot. And this happens to also be our expansion in ascending order. So yeah, fairly simple one, which is the trigonometry expansions in the Maclaurin series.